Good day, students. Today we're going to look at some solutions now to hypothesis testing problems. This is the first in a series of videos on hypothesis testing. So I have a problem here, and we're going to take you through the 5 steps and show you the calculator steps as well. Now the video is fairly lengthy, so if you want to fast forward through anything you're quite confident with, feel free to do so. Alright, so let's have a quick look at the problem. The average weekly hours of tweeting for college students is 2.5 hours with a standard deviation of 0.5 hours. A random sample of 40 local high school students revealed that the mean number of hours tweeting was 2.1 hours. At the 0.05 level, significance level, can we conclude that high school students tweet less per week than college students? Alright, so you'll notice I have here an image of the 5 steps that we normally use, okay, for hypothesis testing. And those 5 steps are: state the null and alternate hypothesis, select the level of significance, identify the test statistic, whether it's a z-test or a t-test or proportional test, formulate a decision rule, and then take a sample, arrive at a decision. And that decision is either one or the other. Do not reject HO, and a lot of people say accept HO. However, that's technically slightly incorrect. You just don't reject HO, but a lot of people use that, so that's fine. We could also say accept HO, okay? And the other conclusion is reject HO and accept HA. So there's the 5 steps. Okay, now I'm going to take that away. We don't need to see that graphic there. And I have a little chart below it that we're going to fill in as we go, showing the 5 steps. Alright, now let me just move this chart up a little bit here. Alright, now the first thing we like to do, of course, is go through the problem and indicate what we know. And I like to do it based on population and then sample. What do we know about the population? Well, the population looks to be college students, and they tell us that the average, which of course is mu, the average, okay, is 2.5, and this is hours. So the average hours of tweeting per week is 2.5, and this is hours. And we're told that it has a standard deviation, so that's sigma, and that's 0.5 hours. Okay, so the standard deviation 0.5 hours. Now, then we look at information from the sample. So I like to separate them sometimes when I'm making sure I have all the information. What do we know about our sample? We do know the sample size, 40 local high school students, so that's n, right? N equals 40. And we do know the mean, which is average, is 2.1 hours. So x bar, which is the mean or average of a sample, is 2.1 hours. Okay, now that's all the information we know from the population and sample. Now let's go through our 5 steps. In our first step, of course, we're asked to find or state the null hypothesis and alternate hypothesis. Notice I have HA here for alternate. Lots of people use H1. Same thing, okay? H1 or HA. Alright. Now HO is usually the status quo, what has been happening. And in this case, we're saying that the mean stays the same, right? Is greater than 2.5, and you can see here that the we're asking if high school students tweet less, and usually the wording of the problem gives you the alternate hypothesis. So we're asking, do high school students tweet less, right? So that's mu less than 2.5. Okay, now a couple of things to remember: that the wording of the problem will give you the alternate hypothesis. The equal sign always goes with the null hypothesis. So look and we indeed have the equal sign with the null hypothesis. Now alpha is a level of significance. It's the probability of rejecting the null hypothesis. So this is given to us. We don't have to choose it. As it says, select a level of significance in the steps. This is already given for us, and it is 0.05. Okay, so there you have it right there. Now, third step is decide to test. Well, very important fact is we know the standard deviation of the population. We know sigma. See it there? And when you know sigma, okay, right there again, that means we use a z-test. Okay? So when you know sigma, use z-test. So we're going to use a z-distribution or z-test, and if they ask you why, just say because sigma is known. Okay? Now, decision rule. What is a decision rule? Now, step 4, often referred to as critical values and so on. So let's do some work on step 4 right here in the red. So step 4, we're looking at making a decision rule. What is that decision rule? Well, first of all, we have to come up with a critical value to test against. Now, we can do this by formula, and we can also do this by calculator, and I'll do it both ways. But in the first couple of videos, I'll show you the formula, but in the other videos, as we go through more problems, we'll just be using the calculator to find these values. So the z, and for lack of a better term, we'll call it CV, critical value. So the critical value for z, the one we're going to test against, is found by using, in this case, the inverse norm. Now in old days we had to look these up in charts, but we'll do this part on our calculator. Alpha 0, 1. Now why did I pick alpha 0, 1? Because in the alpha, it's asking for the area in the calculator when you do that. Now why did I pick alpha? Well, this is what we call a left-tailed test, and a left-tailed test comes from this information right here. So when it says in the alternate hypothesis that we're testing to see if mu is less than 2.5 in the alternate, that means we are doing a left-tailed test. And in a left-tailed test, the area, okay, is equal to alpha. The area for a right-tailed test is 1 minus alpha, and the area for a two-tailed test is alpha over 2. Okay, so this is a left-tailed test because of less than right there. Alright, so we are doing alpha. So therefore, if we go back to our problem here, on our calculator, inverse norm of alpha, which is 0.05, 0, and 1. So let's go over to our calculator and plug that in. So again, all distributions are in right where we find our inverse norms, inverse t's. So go down to number 3. So second function, second button, distribution. Go to number 3, inverse norm, and it's asking you for the area, okay, which we're using 0.05. The standard deviation, okay, which for a z-score is, or sorry, the mean is next. Mu, which is for a z-score, is 0, and the standard deviation for a z-distribution is 1. So we enter several times, and we get negative 1.645, a very common value. We'll see that probably pop up in other problems again. 1.645. So what this is saying, now if I go to negative 1.645, which is roughly right here, okay, roughly. Let me just do that again. Okay, so this is negative 1.645. What it's saying is that this little area in here, right, is 0.05. This is alpha, which is 0.05. Remember what alpha is now, is the probability of rejecting the null hypothesis. reject HO. So our decision rule then is going to be what? If our value is less than negative 1.645, we are going to reject. So if, okay, z, the z-test we run, we're going to run the z-test in a minute, if that z-test value is less than negative 1.645, the critical value, then we're going to reject HO, because that's our decision rule. Okay, so anything down below this area, so anything below here, we are going to reject. Now anything above that, we say do not reject. Now lots of people use the word accept, so I'll do that as well. But technically we're supposed to say do not reject HO, because there could be errors as well, right? So now, so that's our critical value. Now the next thing we need to do is step 5, is need to run the test and make our conclusion. Now what is the test we run? Of course it's a z-test. Now in a z-test we would calculate the z value based on that information, and we would use the formula, and I'm only doing this in the first video, I won't do this anymore, this is just to show you. Divide over sigma divided by root n. And if we plug those values in, we get 2.1 is the mean of the sample minus the mean of the population, 2.5, divided by the standard deviation of the population, which is 0.5, and you divide that by the square root of n, and n is 40. Now if we do that out on our calculator, we get negative 5.060, which is indeed less than negative 1 point, so we are going to reject. However, now let's go do it on the calculator. Now how do we do that on the calculator? Okay, all tests are found under stat, so hit the stat button, go across to tests, go across to test, and you see z-test is the very first one. It's a one sample z-test. Now one sample is not written there, it's understood to be there. Okay, when we get to 2 sample later, you'll see that's number 3. This is a one sample, because we only have one sample, z-test. So hit enter. Now we have 2 options right away, data or stats. Data means if we had the raw data of all the 40 samples, we would plug them all in, but we don't have the raw data. We do have the statistics on that, so we hit stats, enter. Alright, make sure that's highlighted. So the first one is asking us for the mean, which is 2.5. The next one is asking us for the standard deviation, which is 0.5. Next one is asking us for the mean of the sample, which is 2.1, and then the sample size is the next question. Now then it's going to ask you which tail test are you doing. Are you doing two-tailed, less than, left-tailed, greater than, right-tailed? And we're of course doing the less than one, so enter. So make sure that's highlighted and hit calculate. Now look at the z value we got, negative 9.0596, okay, which is exactly the one we got here, rounded off to 60.060. So exact same value. So you can actually do it on the calculator quite easily. Now, so this is our z test value, okay. So over here is our z test value. So I'll put z little t there. Now we can't even draw it on the chart, can we? Because it's down in this region here somewhere. If we go down the chart further, so it's well below our value. So therefore, our conclusion is, since it is less than, right, negative 5.060 is less than negative 1.645. Therefore, our conclusion is reject the null hypothesis and accept the alternate hypothesis. Okay, so we reject HO and accept HA. Now if you go back and look at your calculator, P equals 2.107 e to the negative 7. That means go back 7 decimal places. So really that's just 0.000060 zeros and then 2, 1. So really P is equal to 0. Now, so this is an extra test we do, right? So P is equal to 0. We can literally say that. I mean, it's a very small number. Now, anytime P is less than alpha, which it is, 0 is definitely less than 0.05, then that's also another reason to reject the null hypothesis. So this is basically an extra test here, but it backs up what we have already done with the z-test, right? Okay. Now, last thing to do is make a little conclusion in words. So when you say accept HA, what does that mean? So I'm going back to here. I'm just going to write a little conclusion in words here now before we finish off. What does accept HA mean? Well, accept HA means that the mean number of hours tweeting is less, right? So we can conclude something general like this. The mean number of hours tweeting is less than 2.5 hours. So we can make a general conclusion like that now. So yes, we can conclude, right, that the mean number of hours tweeting is less than 2.5 hours. Alright, so that's an example of a one sample z-test. The next video we'll look at a one sample t-test as well. Okay.